We are going to look at binomial expansion, and in particular at the coefficients. Previous videos I've done, I've used the two normal methods, Pascal's triangle and the fraction numerator and denominator changes for each of the coefficients. However, there is a probability combination formula that's much easier to use, and I'm going to focus on that one today. So let's title this Binomial Expansion with nCr. All right, let's go over what I'm talking about that. We're going to start with a very basic but key one. Let's take a look at x plus y to the 45th power. Well, we'd have to multiply x plus y 45 times, and that's really complicated. You don't want to do that by hand. One of the methods, first methods that you can use to get the coefficients is going to be Pascal's triangle, where that's this kind of setup I'm doing over on the right side here, where the two numbers on top will add up to the number underneath it in the middle. And these are the coefficients of each of the terms if the exponent is 2, if the exponent is 3, if the exponent is 4. Well, we have an exponent of 45. Building up Pascal's triangle to get all those numbers, that's going to be huge and definitely not the best way to do this. So we're going to expand this out to 4 terms. The first term always has a coefficient of 1. Notice over here that all of these have a coefficient of 1. All the way down to 45 it would have had that. Then next we're going to take what is the a and the b. The first term, the a, we're going to put here, and it automatically gets the exponent that is the main exponent that we've been using. Then the one that's b gets put in here, but that has to have an exponent of 0, and the reason is because these two exponents always have to add up to whatever this original one was, which of course is 45. So each of the terms have to have a coefficient. I'll just abbreviate it as that. It has to have the a, which is this part, and it has to have the b, which is this part. Circle that way. So for the second term, automatically every time it's going to have whatever these numbers are. So for if it was an exponent of 2, we'd use this one. An exponent of 4, we'd use this one. An exponent of 45, well, we use all of those except the first one is always 1 and the second one's always going to be the 45, or the number of the exponent. So automatically it's going to be that coefficient. All right, great. So I'll put that in there. Then I'm going to do the same kind of thing that I just did over here with this and with this. So let's put, erase that for a moment now, so we can put the x, which will get a coefficient, and the y, which will get a coefficient. We're going to go down 1 for the first one and up 1 on the next one. So that's very important. We're going to subtract 1 and we're going to add 1, and that gives us our new ones. Okay. So that means, well, then that takes care of the first one. Now, you can put a 1 underneath this to get to do it, because on the next one, a method that you can use would be for the coefficient to put the 45 and the 1 and extend it. So you're going to multiply by the next lowest number and multiply on the bottom by the next highest number. And then we're going to put the x to the 43rd and the y second, so that's minus 1 and plus 1. That didn't work out so well to write those that way. So I'll do it with the red, minus 1 and plus 1 for the next set over. Now let's talk about these for a moment, because this 1 is the same thing as using the probability formula for combinations of 45 things taken 0 at a time. So it's like using these two coefficients. That's not really matching the others, so just more the second one's going to be important, or not exponent that we're going to use. I said coefficient, I meant exponent. Sorry about that. If you entered this into the calculator, you would get the number 1. On the next one, we would get that 45 by doing a 45 and a 1 for the combination, and that would give us 45. On this one, notice that the pattern is we'll keep the 45, but we will go down 1, or up 1 in this, up 1, and when you put that into the calculator, okay, that one gives you 990. Okay. And then we are also going to have the x to the 43rd and the y to the 2nd. Well, when we do the next one, we have a couple of choices. Oops, let's bring this back to where it should be. The next one we can do as 45 times 44 times 43 and 1 times 2 times 3. So what we're doing is we're taking this and we're extending it by putting these two new numbers on it. But that's the same exact thing of doing a combination 45 and 3, which is a good deal easier to do in your calculator. And so if you do 45, 3, you're going to get 14,190. So when we put the x's and the y's with it, we get the 1. Well, we don't need to show a 1. The y to the 0 is a 1. We don't need to show that, or we have 1 times 1. And we're going to get x to the 45th power. On the next one, we're going to get a 45, x to the 44th, and a y. The next one's 990, x to the 43rd, y to the 2nd, plus 14,190, x to the 42nd, y to the 3rd. Notice that each time the coefficients, the hidden one with the y, they always add up to 45. Okay, now let's talk about getting that nCr, which is also sometimes written as CNR or as CNR. So on the calculator, you're going to take, I can't put per picture of it here, but I am going to show for the buttons. You have a second button, and underneath it an alpha button, and underneath that a math button over on the left sides of your calculator. Okay, let's do a basic thing like that. I'm not very good at drawing, but you get the idea that you're looking over and you're looking for this math button here. Okay, now this, by the way, is set up for the TI series. All right, so if you're using a different thing other than the Texas Instrument 83 or 84, then you're probably going to have to find out what it is for your particular calculator. But you're looking for the math button, and when you click on that, what you next get is going to have, let's see, as math, numbers, CPX, probability. There's a couple of choices. But what you'll get next, let's put it over here, math, depending on what you have, you're going to be looking for the one that has PRB. And some of them have another column over here, some of them have different ones here, but what you want is PRB for probability. And underneath that on probability, you're going to see, usually most of the time, one fraction. Oops, that's supposed to be RAC, not where we need it for that, but RC2, you're going to see decimals, or DEC, for changing things on that. Oops, let's get this back up here. 3, you're going to see, oh, wait a minute, I'm on the wrong one. I am sorry. I am playing with it on my calculator, and it's not cooperating it. So hold on a moment so I can turn this off and figure out what to do. So anyway, my point is, let's erase all of that because that was the ones under math. My little calculator froze here, so I'm not able to show you on this one. But here, you're going to see, I think it's 2 is NPR and 3 is NCR. That's what you want to be looking at. The problem you have to do is that before you go to this and press 3 or move down and press it, is you have to be able, back over here, you have to put, oh, let's put that in. You have to take, let's say we take this one. You have to put the 43 in first. Then press the button so you get it and it does nCr. And then you're going to put the 2 in. So that would be for this one that's 990, 45, 2. If you do this, putting the 45 first, going to math probability, nCr, and 2, you'll get back 990. If you did it for 3, you would get back 14,190. That's how you would use it. Go to math button, then to probability, and then down to the third one, nCr. But first, enter the main exponent before going to that. All right, now that you see that, take a moment and do one yourself. Let's say you do this one, x plus y. We'll keep all that the same and to the 52nd power. Do that one yourself. Stop the recording, go look at it, do it, and come back, and I will start it in just a moment, and I'll show the answer for that one. Okay, you're back. So here, what we're going to do is the first term is x to the 52nd power. The second term is 52 x to the 51st y, or y to the first, which we won't show, plus 1326. Oops, I don't know why that switched. Let's get that back to the black one here. X to the 50th, y to the second. Again, that's going to add up to 52 there. Plus 22,100. X to the 49th. Let's clean that up there. 49th, y to the third. And you can get these. This one, the one that's here, would have been C52, 0. This one, you really don't need to use it for these two. But sometimes writing this and this down helps you make sure that you get that it's 52 and 2. And remember, that's a 2 to get this one. And then C52, 3 to get this one. Okay, let's now do one that's going to be a little more of a complicated one by throwing in a coefficient of one of the inside parts. X minus 3y to the 47th power. Okay. Immediately first we have a 1, x to the 47th, and I don't even really need to write the negative 3y, but I will just to be extra meticulous here. The second one is definitely going to have the 47 first, the x to the 46th, and the negative 3y, and now we do it to the first power without needing the 1. Plus, I'm going to use C47, 2. Because this one would have been C47, 0. This one would have been C47, 1, so I need the 2 on this one. And when I do C47, 2, I get 1080. X to the 45th power and negative 3y squared. And then for the next one, I'm going to do C47, 3. Much easier than the other methods to use that in the calculator. So 47, 3, and that gives me a number of 16,215. And then I'll do the x to the 44th and the negative 3y to the third power. Well, where do we go with this? This is 1, this is 1. We have just x to the 47th. But over here, we're going to have a 47 and a negative 3 to multiply. On the next one, we're going to have 1080 and a negative 3 squared, which is just the number 9. And on the next one, we're going to have 16,215 negative 3 cubed, which is negative 27. And then we'll use the x's and the y's with those. So our end result here is x to the 47th. And then this 47 times 3 is negative 141. And x to the 1 down, 46, and 1 up, y to the first, plus 9,700. Get this back to where it should be. Off on me. 9720 x to the 45th, y to the second. I'm going to clean up that 9 a bit there. And the next one has a negative in it, so it's 27 times 16 to 15, which is 437,805, x to the 44th, y to the third. Okay. Now, I'm going to show you a different one, and I would recommend that you do this one yourself. I'm going to stop the video so you can do it yourself. And that one, let's see, I would like to give you x to the x minus 5y to the 29th power. Do it out to 4 terms. So stop the video, take a couple of moments to figure it out, work it out to 4 terms. When you're ready, come back, and you'll see me start doing it. Okay, go. Okay, welcome back. And so for the first term, we know it's 1. We know it's x to the 29th. We know it's negative 5y to the 0. So gone. So it's just x to the 29th. On the next one, it's going to automatically be the 29, x to the 28, negative, whoops, let's get it so I write it more clearly, negative 5y to the first. The next one, well, here I'll use C29 2, because this would have been C29 0, this would have been C29 1, so I need to go with the 2 now. And C29 2 gives me 406. And then it's going to be x to the 27th and negative 5y to the second. So notice how 29 to 28 to 27, and I'll use the green from 0 to 1 to 2. And then the next one's going to have C29 3, which is 3,654, plus 3,654, x to the 28th, and negative 5y to the third. I'm going to make that 5 and negative 5y look a little better, so you can tell that's supposed to be a negative 5 there. So this coefficient is 29 times negative 5. This one's 406 times negative 5 squared, which is 25. This coefficient is 3654 times negative 5 cubed, which is negative 125. So our final answer will be x to the 29th power minus 145 x to the 28th y plus 10 150 x to the 27th y squared minus 456 750 x to the 26th y to the cubed. Now, important thing to recognize here is the fact that 2 of these have negatives, because this was a negative to the first power and this was a negative to the third power, so negative times negative canceled, the next negative stayed in, as opposed to this one where the negative canceled out, negative 5 squared. So we now have a good answer for x minus 5y to the 29th power using combinations in the combination formula rather than doing the multiplying out of the numerator and denominator of the fractions. I hope this helps with understanding how to do that, because doing it this method is a good deal easier, and so it would be worth getting comfortable with that so you can use it when you're doing tests and other times when you have to expand binomials. Okay, here I'm going to make sure I just go over. That's what I did for each of these in order for them to work for us. Okay, so thank you for watching, and hopefully that helps to know how to use the combination formula. And if you want just to review that, you get to in the calculator by going to the math button. I want all of that to disappear. Math button, going to the probability button inside the math menu, and then using nCr. But you first have to enter the main exponent before you use nCr. Okay, thanks for watching, and I hope this was helpful.